Okay, we are going to solve this initial for your problem. We have dy dx is equal to e to the y times sine x, and then y of 0 is equal to 0. So let's focus on getting the general solution first. Well, we have dy dx like this, so let's multiply dx on both sides, and that's my recommendation. You should not have the differential in the denominator. Then when you do that, they cancel out, of course. And if you look at the right hand side now, we are in the x world. So sine x stays, but e to the y has to go away. It's okay, I can just divide both sides by e to the y. And on the left hand side, I will just put down 1 over e to the y like that. So this is pretty much how we get ready. Separate the variables. Here we have y and dy's together, and then here we have the x and then the dx together, right? So that's how you keep track of everything. Now we have 1 over e to the y dy. We want to integrate that. And to get ready, I would write this as e to the negative y. And then this is dy. And that's equal to the x part, which is sine x times dx like this. And now we can totally integrate both sides. On the left-hand side, I can just, the integral of e to the some constant times y is just that pretty much, e to negative y. But we have to remember to divide it by the derivative of this. The derivative of negative y is negative 1. So we will have to divide it by negative 1, which is the same as saying multiply by negative right here. And you don't have to put down the plus c on the left-hand side, just put down the plus c on the right-hand side. That would be good. So this is equal to, the integral of sine x is negative cosine. Good. Negative cosine x, like that. And remember, we have to put down our constant. And I'll just put down plus c1 like this. Okay, so notice that we do have a negative. Before I can take the ln both sides, I should really get rid of this negative. Okay, so if I don't, then you have ln of negative times something that's always positive. That means ln inside, that inside is always negative. That's no good. So let's divide everything by negative 1, and you will see why I want to do that. This and that cancel, that's good. So you have e to the negative y. This and that cancel, you have positive cosine x. Okay, c1 is a constant. Divided by negative 1, you have negative c1. But that's also another constant. If you would like, you can keep it as minus c1, but I would write it as plus c2, just to get more exercise with the constants. Anyway, now we take the ln, both sides, this and that cancel, and you see negative y equals to ln with both of these things inside. So natural log of cosine of x plus c2. But we're almost done, so let me just lose the subscript. So I'll just put it on like this. If you want, put on C2, sure, why not? And of course, divide both sides by negative. Finally, we see y is pretty much negative on the left-hand side now, ln of cosine x plus the constant. Because we are done, so I'll just put down a c right here, says seriously, okay? All right, now, to find out what this c is, come back to here. This tells us x is equal to 0 and y will be 0. So I will just put this down. Y is 0. That's equal to negative ln cosine x is 0 here. And we add c to that like this. And left-hand side is 0. This is negative ln. Cosine of 0 is 1. So we have 1 plus c like this inside. To solve for c, we can divide both sides by negative. So you're talking about ln of 1 plus c equals to 0. c is 0. So finally, the answer is y equals to, and let me just write it down as y as a function of x. Okay? It's equal to negative ln of cosine of x plus c, which is 0, so you can just put it down like that. You can just put it down like that. And if you want to be fancy, you can put the negative to the power and this becomes ln, and it becomes 1 over, so it becomes secant of x, like that, if you would like. So either one is okay. So probably I'll just box this right here, and box this like this. Box this like that. And once again, this is because a -1 means you do cosine x to the -1, which is 1 over cosine x, which is secant x, like that. Anyway, this is it.